Okay, all of you turn on your video. Jodha, then Wilson De Burma. Harvisha Rani, okay. Senjam, Benison, Laishram, Happy Singh. Okay, so unmute yourself. All of you unmute yourself. Okay, you tell me one answer. Okay, you tell me one thing. Whenever I ask you something, why don't you reply? If you are attending the class, why don't you reply? You tell me that one thing. At least you can write in the chat box, is it? Whenever I ask you something, at least you can write in the chat box, is it? Okay, what about the other students? Only 25%. Okay, so from next time, if I ask question and if I don't get any response, okay, so I will not give you the attendance. Okay, this way it is very difficult for me. Okay, it is very difficult for me to make it understand. You are not responding to anything. Only one or two students. This Shiroda, then this sometimes Wilson, sometimes Michelle, and sometimes Oinam. Only 4 or 5 students will respond every time. And what about the other students? Why don't you reply? At least you can write in the chat box, is it? Okay, so this is the first chapter, okay, and it is the very simple one. In the later classes, I think this semester, whole semester, we have to do online classes only. So if you don't respond, whether you are understanding or not, if you don't respond, then you will find it very difficult. Okay, you will find it very difficult to solve the questions. In your final exam also, you will find it very difficult. So whenever I am trying to teach you, at least you respond, whether you are understanding or not, you have any doubt, anything, you just tell me. Okay, at least in the chat box or personally also you can tell me. Okay, so that I will understand that you are at least you are attending the classes. Not only attending, you are trying to understand these things. Okay, so I hope all of you will cooperate from this time onwards. Is it? Can I expect that from you?
Okay, sir.
Can I expect
Yes, sir.
that from you? Yes.
Yes, sir.
Okay, so I hope from next time, not from next time, from this class onwards, I will get some positive response from you. Okay, so let us go to the problem. I hope you have got the value of Na and C. Is it? Okay, so now I will share the screen. Okay, so I am sharing the screen. Okay, so can you see the screen? Okay, so did you get the answer? Shirodha, did you get
Yes, sir.
Sir.
equal to this one? Did you get the answer, Shirodha?
Yes, sir.
And did you get this? N equal to 159.5?
Moment of, yes, sir. And moment of resistance is 27.7.
No, it is not 27.7. See the answer? Check the value. Half sigma CBC D into N Did you get this answer? Did you get this answer? Moment of resistance 15.75 kilonewton meter.
I thought it was under reinforced.
No, it is not under reinforced. You can see the values. If NC is less than, means critical neutral axis, if it is less than actual neutral axis, then it will become over reinforced. So for over reinforced, this is the formula to find out moment of resistance. So put the values in this equation. Okay, so did you get this answer? Moment of resistance 15.75. Okay, so now see the question. After getting the moment of resistance, you have to find out another value. You see, it is written here, if the span of the beam is 5 meter, find the maximum distributed load which the beam can carry inclusive of its own weight. Okay, so that means if the span of the beam is 5 meter, I hope you have understood. What is the span of the beam? Span of the beam is, length of the beam is given 5 meter. We have to find out maximum distributed load. That means maximum UDL value you have to find out. Maximum uniformly distributed load you have to find out. Okay, from the value of moment of resistance. Okay, in the last class I told you that moment of resistance is nothing but your bending moment, maximum bending moment, which the beam can, okay, which the beam can offer against external loads. Okay, so now we have got the value of moment of resistance. Okay, and we need to find out the value of uniformly distributed load. Okay, so let us assume that the value is W. We don't know the value now, so let us assume that it is W. Let W kilonewton per meter be the uniformly distributed load. Okay, so now your beam is a simply supported beam. Okay, so for a simply supported beam, can you tell me the formula of maximum bending moment? Can anyone tell me what is the formula to find out maximum bending moment for a simply supported beam carrying UDL? Can anyone tell me what is the value of maximum bending moment?
Sir,
Yes.
your voice.
What is the value of maximum bending?
Sir, sir, W into L by 2.
W into?
L into L by 2.
No, that is the bending moment at the center. If your UDL is carrying
Sir,
UDL, if the beam is carrying UDL over the whole span, then in that case, what will be the maximum bending moment?
sir,
Yes.
sir.
Yes, tell me.
I think it's W into L square. W into L square by 8.
Yes, good. WL square by 8. WL square by 8. Okay. The maximum bending moment for a simply supported beam carrying UDL is WL square by 8. Okay. So WL square by 8 it is the maximum bending moment, and that bending moment is known as moment of resistance. So can we equate the two equations? WL square by 8 equal to this one. Can we do this? Maximum bending moment is nothing but our moment of resistance. So can we equate that equation of maximum bending moment WL square by 8 equal to 15.75? Yes or no? You tell me whether we can use the equation WL square by 8 equal to 15.75. Can we use the equation?
I don't know, sir.
Yeah, I am saying that moment of resistance is the maximum bending moment that the beam can offer. Okay, moment of resistance is the maximum bending moment a beam can offer. So we know that the maximum value of bending moment is WL square by 8. So can we use the equation WL square by 8 equal to 15.75?
I don't think so, sir.
Why you don't think so? See, I am saying,
Sir, if it is same, then we can go
yeah,
ahead.
if it is same, no, it is the same only. Moment of resistance, that means the maximum bending moment which your beam can offer. And we know that the value of maximum bending moment is formula is WL square by 8. So can we use the equation WL square by 8 equal to 15.75?
Yes, sir.
Yes, we have to use that equation. See here, maximum moment is WL square by 8. Okay, and this whole value we have already calculated, moment of resistance W 15.75. So WL square by 8 equal to 15.75 here. L is given, span of the beam is given 5 meter. So only unknown is this W UDL. So find out this value, you will get 5.74, 5.04. So do you understand why we have used this formula? Why we have equated these two equations? Do you understand now? Do you understand now why we have used,
Can you explain it once again, please, sir?
why this 15.75 equal to WL square by 8? Do you understand now?
Sir, sir, can you please explain again? Sir,
Okay, so this value is, we have calculated the value of moment of resistance, is it? Okay, so moment of resistance is the maximum bending moment which the beam can offer. Okay, moment of resistance means the maximum bending moment which the beam can offer against external load. Okay, and we have got the value of moment of resistance, and we also know that the value of maximum equation of maximum bending moment is WL square by 8. So this equation and this value, they must be equal, no? We know the equation of maximum bending moment is WL square by 8, and we have got the value of moment of resistance 15.75. Then we have to equate these two values, is it? WL square by 8 equal to 15.75, because they are the same. They are the same. This is the formula, this is the value. So WL square by 8 equal to 15.75. So we need to calculate this W. W means our uniformly distributed load. So if you solve this equation, you will get 5.04 kilonewton meter. So do you understand now? Okay, to Achumi.
yes, sir.
Okay.
Yes, sir.
Okay, thank you. Okay, so in the meantime, you do one thing. All of you write down your name and enrollment number in the chat box. Okay. I will give you the attendance at last. Okay, when our classes is about to over, I will give you the attendance. But now you write down your enrollment number and name. Okay, so this roll number 40, enrollment number 49 and 50, Rongsaldo T. Sangma, and this Padang PG. So if anyone have any contact with them, okay, please tell them to come and attend the class, at least attend the class. Okay, otherwise, if their attendance will be less than 75%, so then they can't appear the exam also. Okay, if you have any contact, if anyone have any contact with enrollment number 49 and 50, Rongsaldo T. Sangma and Padang PG. So if you have any contact with these two students, you tell them to attend the class. Otherwise, their attendance will be less than 75%. And this time, if your attendance will be less than 75, so in that case, we can't help you. Okay, you can't. You won't be allowed to sit in the exam. Okay. And also, you tell this Nyami Kamchi. Okay, Nyami Kamchi, roll number 39. Nyami Kamchi, he has attended only one class. You tell this student Nyami Kamchi to attend regularly. Okay, so I will see it later on. I will share a new phone. Ashok Tangu, present or absent. Ashok Tangu, absent. Okay, so let us see. Okay, so this problem, all of you, I think all of you have understood this problem. All of you have understood this problem, yes or no? If you have any doubt, you can ask me now. For this problem,
Yes, sir.
yes, no? It is the same problem, only in this case,
Yes, sir.
only you have to find out this
Yeah.
UDL separately. Okay? Okay, and one thing you have to remember, whenever it is not mentioned whether your
Yes, sir.
section is balanced or under enforced or over enforced, always your first aim will be to find out what will be the type of section, whether it will be your balanced section or under enforced or over enforced. Then only you can use the formula which is applicable for that particular problem. Okay, so only in the first problem it is mentioned it is a balanced section. That's why we can directly use the equation of moment of resistance for a balanced section. But in the remaining problems, you can see not in any problem it is not mentioned whether your section is balanced section or under enforced or over enforced. So every time we have to find out first what will be the type of section, and after that only we can use the equation of moment of resistance. Okay. Okay. So let us see the next problem. See the next problem. Read the question. You try to find out first what is the type of section. You try to find out. You try to, for this problem also, first your aim is to find out what is the type of section. Okay, so first find out that what is the type of section, whether it is under enforced or over enforced or balanced section. You find out that first. All of you try to do it. All of you try to find out what is the type of section. Did you get the answer? Critical neutral axis. What is the value of critical neutral axis? What is the value of critical neutral axis? Did you get the answer?
144, sir.
Critical neutral axis width. Yes, 144.13. Yes. And then what is the value of actual neutral axis? Okay, what is the value of actual neutral axis? Did you find out the value? You are not using your calculator. Huh? You're not using your calculator. Or? Enrollment number 25. Is he present? Hijam? 25. Absent. Then enrollment number 32. Ramthama Debbarma. 32.
Sir, present.
Present.
Present, sir.
Okay.
Present, sir.
Okay. I've got. Okay, so did you find the answer? Anyone? Depth of actual neutral axis, how much? You are taking so much time. It will be, depth of actual neutral axis will be 116.96. Did you get the answer? 116.1696. This is the critical neutral axis depth. This is the actual neutral axis depth. Did you get the value? Shirodha, did you get the answer? This one? Okay, to Achumi. Okay, so if you compare these two values, then what will be the type of section? It will be under reinforced. Okay, so for under reinforced section, the moment of resistance will be known as, or will be find out by this formula. Moment of resistance equal to sigma st into ast d minus n by 3. So if you put all the formulas, all the values, you will get moment of resistance equal to 42.61. 42.61. Okay. So next, what we have to do, another part in this problem again, we have to find out the maximum UDL. Also find out the safe load, including its self weight, if the span of the beam is 2 meter. Similar to the last problem, exactly same with the last problem, but in this case it is mentioned what is the type of the beam. It is your cantilever beam. So can anyone tell me, if a cantilever is carrying UDL, what is the maximum value of bending moment? Can anyone tell me what is the value of maximum bending moment for a cantilever carrying UDL? Anyone? What is the formula of maximum bending moment for a cantilever carrying UDL over the whole span? No one knows the answer? No one? Anyone have any answer? If you know, you just tell me. If you don't know, you just tell me. We don't know.
Sir, we don't know.
Yeah, yes. We don't know. Okay. We don't know. You don't know. Okay, so the value of maximum bending moment.
I don't know, sir.
Yeah, it will be WL square divided by 2. Okay, for a cantilever, maximum value of bending moment is WL square by 2. Cantilever carrying UDL over the whole span. The value of bending moment is WL square by 2. So now, can you find out the value of this W? Because it is mentioned that you have to find out the value of W, safe load, including its self weight, if the span of the beam is 2 meter. So can you find out the value? Can you find out the value of W? Can you find out the value of W?
Zero.
Can you find out the value of W? Maximum value of UDL, I told you in place of WL square by 8, now it will be WL square by 2. You have got the value of moment of resistance. Can you find out the value of W? It's so simple. Why you are not? WL square by 2, maximum value of bending moment in a cantilever is WL square by 2. 2 equal to moment of resistance, this one. Find out the value of W, you will get 21.30. In case of simply supported beam, the value of maximum bending moment is WL square by 8. But in case of cantilever, the maximum value of bending moment is WL square by 2. You have to remember these formulas. These formulas already you have studied in 3rd sem and 4th sem. Okay, so I hope all of you can remember the formula, as well as you have to know how we have got the formula. Okay. Maximum bending moment in a cantilever beam is WL square by 2, and maximum bending moment in a simply supported beam is WL square by 8. Okay, and this maximum moment is nothing but your moment of resistance. For any beam, the value of maximum bending moment is your moment of resistance. Okay, for any beam, the value of maximum bending moment is your moment of resistance. Okay, so the remaining problems I will discuss in the next class. Okay, but today whatever problems we have discussed, today whatever problems we have discussed, I hope all of you have understood these problems. But then also, if you have any doubt, you can ask me now, because in the next class we will start the next problems. So this was our first problem. In the first problem, we have to find out depth of neutral axis and percentage of steel. Here in this question, I told you so many times that directly it is mentioned it is balance section. So we can directly use the formula for a balance section. Okay. So first we need to find out the value of sigma CBC from table number 21. Then we need to find out the value of sigma ST from table number 22 of IS code. Then we need to find out the value of M. M means your modular ratio. Modular ratio was 280 divided by 3 sigma CBC. This is the formula. By using this formula, we can find out the value of modular ratio. Then for balance section K equal to this 93.33 means actually the value formula is 280 by 3 divided by 280 by 3 plus 140. 140 means sigma ST. This formula. K formula is this one for a balance section. Okay. 280 by 3, if you divide it by 3, you will get 93.33. Okay, so after getting the value of K, depth of neutral axis, we know that it is n equal to KD. So we need to find out the value of n. Just put the value of K. D is unknown, so this will be your answer. Okay. So after getting the value of n, we need to find out the percentage of steel. So for that, we need the value of J. Then we have a relation between J and K. This is the relation, J equal to 1 minus K by 3. Then after that, moment of resistance equal to RBD square or QBD square. We know the value of R, this one. Just put the value here. This will be our moment of resistance because B is unknown, D is unknown. Next, percentage of steel formula is this 50 K square divided by M into 1 minus K. K value we have got 0.4. M value is 13.33. If you put the value, you will get percentage of steel equal to 1%. Okay, percentage of steel is 1%. Then for the second part, everything is same. Only sigma ST value will be changing. Only sigma ST value will be changed. The remaining part is same. So in the second problem, we have seen how to find out moment of resistance. In this question, we don't know whether the section is under reinforced or over reinforced or balanced. So our first aim will be to find out what is the type of section. And for that, we need the value of actual neutral axis as well as critical neutral axis. Because after comparing the values of NA and NC only, we can say what is the type of section. Okay. So to find out the critical neutral axis, we have this formula. M sigma CBC divided by sigma ST equal to NC divided by D minus NC. This is the formula to find out critical neutral axis. All values are known except NC. So we have got the value of NC 144.13. Then actual neutral axis formula is this one. From this formula we can find out the value of N. So in this case we have got the value of N is 139.13. So now we have to compare these two values NA and NC. This is 144, this is 139. So actual neutral axis is less than critical neutral axis. So we can say that our section is under reinforced and the moment of resistance will be calculated by this form, which I have already told you, and I have already given you the PDF containing these formulas. Okay. Second problem is exactly same, but in this question directly sigma ST, sigma CBC, M, everything is given. So this is more easier than the previous problem. Okay. Everything is same. We need to find out NC, then N. We need to compare these two values. Okay. So in this case, we have got the section as over reinforced. So for over reinforced section, this is the formula to find out moment of resistance. Okay. In the second case, again, same problem. First, we need to find out moment of resistance. Then, in this case, we are asked to find out maximum UDL. Okay. So first, we will calculate moment of resistance. And we also know that moment of resistance is the maximum bending moment. Okay. So we have the formula for maximum bending moment, WL square by 8. So we can equate this MR equal to WL square by 8. And if you solve this to equation, then you will get W equal to 5.04. Okay. In the second question, in the next problem also, same problem. Only here it is mentioned your beam is cantilever. Okay. But The remaining procedure is exactly same. First, we have to find out moment of resistance. We need to find out NC. We need to find out N. We have to compare these two values. Then we have got, in this case, it is under reinforced. So we have calculated the moment of resistance. Then in case of cantilever beam, the maximum value of bending moment is WL square by 2. So WL square by 2 equal to MR equal to 42.61. So if you solve the equation, you will get W equal to 21.3. Okay. So these are the problems which we have discussed today. I hope all of you have understood the problems. But then also, if you have any doubt, you can always ask me. Okay. You can ask me in the class. You can ask me later after the class also. You can ask me. Okay. I will try to give you the explanation, or I will try to make you understand. Okay. If you have any doubt on these problems, I will share the PDF after the class. You go through the PDF. Okay. Then again, if you have any doubt, then you can always ask me. Okay. But you go through the PDF. Okay. I will share the PDF now. You have to go through the PDF. Otherwise, in the next class again, we will discuss the remaining problems. So if you don't see this PDF, whatever I will share with you today, again you will forget everything. Okay, in the next class you might forget everything, and in that case it will be difficult for you to understand. Okay, so I wish and I hope all of you will go through it. Okay, so this is all for today's class. So now I am closing the meeting. Okay. Okay, so thank you everyone. I hope we will meet in the next class. Okay, thank you.